Welcome to video 5 in a series of introductory videos for the InventorCAM CNC programming software. This video's topic is setting up a turning or mill turn part. So we begin with the Inventor part here, and I'm just going to go to InventorCAM, New, and we have the option of turning and mill turn. Now with InventorCAM, you actually are sold both modules, and what actually controls what you're doing inside the part is your post-processor. So to begin, I'm going to recommend going with the mill turn, simply because both of them allow you to do turning toolpaths, but the mill turn actually allows you to have the full functionality of the software. Similar functionality that you would have gotten with a full mill turn module, or some turning, some milling aspects as well. Essentially for turning, if you're just doing pure turning operations, what the mill turn module will allow you to do is set up multiple MAC positions. So we're going to see that once we get into the Coordinate System Manager. But essentially everything we're doing from the beginning of this to first adding turning toolpaths is a similar procedure that you would have seen in video 3 for a milling part. So I'm going to click on mill turn, and we'll see the same window here. So we're just doing some file management questions here, similar to what you saw in video 3. We're just going to choose where we'd like to save this part, what name we'd like to give the part, and this is just the address of the original InventorCAM part, or the Inventor part, and which units we'd like to work in. So as soon as I click OK, it closes that original part and opens up the design model, which is our copy of the original Inventor part that we can program off of. If we need to make some changes to it, we can affect those changes to this copy, and it won't be seen in the original Inventor part. But this copy of it is still associative to the original Inventor part, meaning that if the original Inventor part has any changes done to it, we will see them here on our copy, and they will make changes to our toolpath as well. So again, the setup here is similar to what you would have seen in milling. We're just going to choose a post. In this case, I'll just continue with this DMU and coordinate system. What makes turning a little different, obviously, is the setup of a turning part is going to be centered around the rotary axis. So instead of top corner model box, we'll use the additional function of center of revolution face. I'll click on select face. So now any cylindrical face I choose, it's going to place the z-axis as the rotary axis. So I'm just going to choose this outer edge right here, and there's our axis right there. So if I turn this thing around, our z-axis pointing positive out, that is the direction that our toolpaths want to come in. So always remember that coordinate systems, the z-axis is the tool axis. That is especially here true here for turning, in that as the z-axis points out here, my toolpaths are going to come from this direction and turn in that direction. Now, what I normally do here is I actually orient the z-axis directly like that. Now, if on your mill turn machine or on your turning machine, it is the x-axis, that is the rotary axis, you can use any one of these functions over here to flip the part around to get that. I'm actually going to use the flip around Z so that I can get the x-axis to point towards the keyway. So it rotates it by 90 degrees every time, and now I have the keyway, the x-axis pointing at the keyway. The only reason I do this is for setup purposes. I imagine that that keyway could be used to locate the part, so that's really all I'm doing here. Now, if this was a purely rotational part and there were no distinguishing features to give it any kind of rotational index, I could just put that X and Y in any direction I want. I'm just choosing the keyway there because it's something that we could locate off of later on. So I'll just click the green check mark. And if I go back in there, we'll see why I chose the mill turn module over just the turning module. This actually allows me to go back in and set up a MAC 2, position 1. So this will actually be the coordinate system for the backside. So again, center of revolution face, I'll click on that. It places the origin in the same spot, but I actually want it on the back face. So I'll just click on change to opposite. I'll flip around Z so I can get the X pointing at the keyway once again. And once I click the green check mark, I will have a coordinate system for my backside, for side 2. I can actually do turning toolpaths on the backside as well. Stock. Again, stock is similar to what we would have seen in video 3. In this case, though, we're going to take advantage of some of the turn-based stock definitions. So STL, you could still use that if you were going to turn an STL file. Something that represents a previously turned part, previously machined part that we're just going to do some additional turning on. You can use the STL format file here to represent that. if you have a file that's in any other format, let's say it's an IGES file, a step file, or a Parasolid, you can bring that in here and translate it into an Inventor part, and then select the 3D model option to choose that part. Again, for a casting, a previously turned part, anything that is not a very basic definition like the ones in the other part of the list. So revolved around Z is essentially, we're going to take an outside contour and revolve that around our rotary axis. I don't have that here, so I'll go right to cylinder. So cylinder is a very basic definition. I'm just going to say relative to the model. When I click on the model, it'll place a cylindrical definition. So we have the outer diameter, the inner diameter, and the length of the bar stock. In this case, though, I'm going to just put it as 10 thou from the positive Z, 10 thou from the negative Z, and externally, I'll just put 10 thou as well. I'm just going to put it just a little bit of material so that we have something to turn. And that is actually the major difference between turning and milling. I want to put some material on the faces and the OD so that InventorCAM recognizes that there is some additional material that can be removed by turning operations. If I don't have any material there to remove in this simulation, then it won't generate the toolpath because there is no material to be removed as far as it can tell. So that's really why I'm just putting that 10 thou there. You can consider this to be something just to true up the part, even if it is almost on size. So I'll click on the green check mark, and as soon as I do that, it'll actually generate a turned profile of the stock. Now, if we go back in there, I'll show you what actually would happen there. So that was actually just the envelope that was generated. That's all that is. So I could uncheck that box if I didn't actually want something to appear on screen. Next is target. Again, target is really just the final part. So we'll just click on that. And as soon as I click the green check mark, it's going to create that same turn profile of this target part. Now, the thing to keep in mind here is we have envelope and section. There may be parts where you want to have not just a turn profile, but maybe something representing the top and the bottom. Maybe you have a lower turret or something like that. Section actually takes a cross-section of the part rather than just a rotational envelope. Rotational envelope is when they take the part and rotate it around, and all the external edges get represented into a turn profile. Section actually just takes a cross-section right down the XZ plane, and that is the cross-section you're going to use for your turning. Okay, so I'll just click on the green check mark. And if we zoom in, you can actually use this view up here to see it from the side. So there's our 10 thou all the way around. And that right here represents the turn profile. So that is what we're going to use in terms of turning geometry. So click on the green check mark. We are done with our stock, our target, and our coordinate systems. And we are almost there to adding turning toolpaths. The only thing left would be to add a machine setup. So I'll right-click on Operations, Machine Setup, Add at the start of the tree. And all we're doing here is relating the coordinate system to a fixture. Now in turning, we actually have default fixtures we can use. So if I go to Fixture, click in this empty space here, click on the 3 dots to browse to the Fixture Manager, and we'll see that we can actually define a standard chuck, standard jaws. So right here, all we're doing is telling it where on the jaws we'd like the part to sit. So there's a representation of our jaws. And that point right there is just that point there. I control where that point sits here in terms of diameter and here in terms of axial position. Now, if I highlight that, I can actually freestyle wherever I'd like to put the jaws. I can actually choose projection points as well. If I just do something like that right there. Now, I probably want it to sit somewhere over there. And if I don't think that that is a good representation of my jaws, or I actually have definite dimensions of my jaws, I'll just come over here and change the dimensions of the standard jaws. So that might be more representative of the jaws. Now, this is only one type of definition. There's actually 3. So the one I just used was the standard. I just used a standard definition of a 3-step jaw, told it the axial position, the diameter position, where it's sitting on the jaws. If I used user-defined, I would actually be able to choose a sketch that represents the cross-section of my jaws and then define that almost the same sort of way, axial and radial dimensions. In terms of fixture 3D, that actually brings me to a solid selection screen. So if I had a solid model of my jaws, I can select that from here as well. But I'm just going to go with the standard jaws right there. So that assigns clamping fixture to Mac 1 position 1. If I click OK, there's my setup. So that is how I'm going to tell InventorCAM that all these operations that fall under this heading here are going to use those jaws, and they're for Mac 1 position 1. I'll also create a similar machine setup when I do operations on side 2 using Mac 2 position 1. Any other questions on this or anything else from InventorCAM? You can always call us at 1-866-975-1115 extension 2. You can send us your parts and your questions via the ticket system at solidcamsupport.com, or stay tuned for the rest of the videos in this series. Thanks for watching.